Hello, my name is Nguyen, and this is my RoboWrestling PCB tutorial. Hopefully this is the last video I will make for this series for RoboWrestling, and yeah, let's get into it. So to start, what is a PCB? It is a printed circuit board. So you can think of it kind of like a breadboard, but all of the wires are inside the board instead of flying everywhere. So as you can see on the picture on the left, the wires are like literally everywhere. It looks kind of messy and it looks gross. But we can condense it into a PCB. So as you can see, the wires are kind of inside of the board and they're not flying everywhere, as you can see by these lines. Okay, so the first thing we're going to try to do, but it's not going to work, is to update the PCB from the schematic. We're going to click this icon at the top here and we are going to get some errors. So I can show you what that looks like. This is a different schematic than what I did in the schematic video. This is because I'm lazy and this will allow me to make less connections. But the idea is pretty much the same. I have a microcontroller, some motor drivers, distance sensors, line sensors, star module, and a battery. And these motor drivers are external. They are not on the PCB. So I just have screw terminals for these. Okay, so we are going to update PCB from schematic. See what that gives us. What? How do I have no errors? Wow. Okay, that wasn't supposed to happen. But it should give you some errors. I think it's because I already did this previously, but yeah. So if you do get that error, as you should, you're going to need to assign footprints. So footprints are pretty much the things that go. It's kind of like what the component looks like on your PCB. So we are going to click Tools and Assign Footprints. I'll show you what that looks like here. Tools, Assign Footprints here. Wow. Why? Okay, so so the reason I didn't get that error is because the footprints were already assigned. I'm not sure why, but that's whatever. So we're going to need to assign footprints to these. So we're going to start with capacitors and inductors, and this also includes resistors as well. Let me. You want to get size 0A05. I said this in the last slideshow. You can type in capacitor 0805 and you should get something that looks like this line. I would recommend the hand solder type. So we go here, we can type in capacitor 0805. And there's the hand soldered one here. So we can just spam this. Okay, one more. Alright, yeah, that's pretty easy. Okay, so the next thing we want to do is add our screw terminals and our connectors. So I'm actually using JST connectors for this model as well as screw terminals. So we're going to be using both of those. We're gonna be searching for 0x02 or 0x03, but if you have something like 4 or 5 or like however high it goes, you can use those as well. But the general form of that is gonna be something like this. So we can type in connector 01x03. We have a lot of options. We can try to narrow it down. We can add the size. We can do, ours is 5.00 millimeters. And then narrows it down a little bit. I'm going to type in a horizontal to get the verticals out. And we want to select, I think it's this one. And this one's going to be for our motor driver power. And then our motor drivers. Okay. And for the sensors, I'm actually using JST connectors. So let me look at what I did for that. I typed in JST. These are 2 millimeters horizontal. 301x03. Maybe 1x03. Okay, and we have some options here. I'm going to choose this one. And this is for pretty much all of my sensors. What the heck is this? Okay, this is battery, never mind. Okay, so we got the connectors out of the way. Okay, we actually have one more connector. It's the battery connector. So, you can check your battery's connector size. Normally, it will say something on the battery when you order it. And there's a lot of connector types, but if you're using an XT30, it may look something like this. I think I'm using an XT60. So I will be typing in XT60. But some things to pay attention to, you want to look at if it has -M or -F at the end of it. That stands for male and female. It could depend on your battery, so just look at it. 0x02 versus 0x03. There's the 2-pin option versus the 3-pin option. I think mine is 2-pin, so we will go with that one. And then you also want to look at size. Make sure it's the right size. Okay, so for mine, I used an XT60. Yeah, XT60. And this should be in here. Yeah. Now we're going to go with the vertical. And if you don't know what any of these look like, you can always go into the PCB editor and you can type in the name of the footprint. You can place it and see if it's the footprint that you actually want. This one, we want the female version, so we can do this. Oh, that is not the switch. We want it on this one. Okay, so we have a couple things left. The Arduino Nano, the fuse, and the switch. Okay, so something to consider is what if my parts aren't on the KiCad footprint library? So the first thing you want to do is go to snapEDA.com. You want to search up your part, download the footprint, and unzip the contents. And if you need better instructions, you can click on this link. And you can go back to assign footprints and add it. I could just show you that right now. Let's search something up random so I'm not duplicating anything. Let's go with Kui Ink. Wow, that is a footprint. So we're gonna download this. Okay, it should be in our downloads. We're gonna move it to KiCad stuff. What was it called? PDM2. It was this one. I'm going to extract it. Okay, so there's a how to import here if you are confused by my instructions, but we are now gonna go to KiCad. We're gonna go to this menu. We're gonna do preferences, manage footprint libraries. We're gonna hit this folder here, and for this step, it's going to ask you to select the folder that it's located in. So I can click on this one. You can see there's nothing in here, but I just need to select the folder. So we're gonna select the folder, and as you can see, it's added here. I don't actually do this part. I just didn't want to download another Arduino. So imagine I imported the thing for the Arduino, the fuse, and the switch. So we can click here, and this one was called Arduino Nano. What is this one? Oh, I guess it was already in here. That's cool. Our fuse name was C1F. See if that's in here. No, FUSC. Here it is. And our switch name was JS10. I think it was this one. Okay. Okay, so we assigned footprints to everything, which is pretty good. So now we can go out, save, and now when we try to update PCB from schematic again, we can update. It gave us 4 warnings. No net found for blah blah blah, blah blah blah, blah blah blah. You can read through these. I don't think they're too relevant, at least for my case, but sometimes it might be, so you definitely want to check that out if it does seem like a problem. Okay, so here's all of our footprints. As you can see, here's our Arduino Nano. We got some screw terminals, JST connectors, and we got all of our capacitors in a line here, battery, switch, fuse, another screw terminal. Okay, cool. Yeah, so make sure your footprints are filled out. This is something that it might look like if yours is more complex, but yeah. Okay, update PCB from schematic. Yeah, we just did that. So before we start, we want to make sure that we know what our PCB dimensions are going to be. So definitely check with your mechanical member about that. This could be really small. This could also be big, but you definitely don't want it bigger than whatever your chassis dimensions are. Okay, so to set the dimensions, we're going to select edge cuts on the right panel. We're going to select the rectangle on the smaller panel, and we're going to make a rectangle with the desired dimensions, and yeah, this is our border as I said earlier. So we go here. Let's move all of this to the left for now. And okay, first step is to select edge cuts, which is right here. We're going to make a rectangle, and this one I want to make it 75 by 50 because that is what my mechanical member told me. 75 millimeters by 50. Okay, nice. Okay, so this is our border. Yeah, pretty simple. Okay, next we're going to move the microcontroller. I recommend placing it maybe on the left side, but you'll just want the USB side closer to the edge for convenience. So we're going to go here. Let's grab this one. We rotate it. I'm using the R button because it's nice and easy. And we can place like that. Cool. Alright, so next we're going to place our screw terminals or connectors. So I'd recommend placing them on the edge. It's just easier to connect stuff like that. And then also place the connectors close to where the other component is going to be. So for example, if I have a front facing distance sensor, I probably want to put that in the front of the PCB, something like that. Only the pad needs to be on the border, but you do not place the pad off of the border. So we can do that real quick. Here's my right motor driver. let me see where I put this. We're gonna put something like this. Make sure the pad is on within the border. I put my left motor driver somewhere right here. I didn't make myself enough room. Move it down just a little bit more. Something like this. And I can move this. That's good enough. And with empty power, I'm gonna put this here as well. And as you can see, my right motor driver is on the right side, my left motor driver is on the left side, because mechanically that's where they are being positioned. We have our back line sensor, put this in the back somewhere. Right distance sensor, we could put it probably like right here. Left, we can follow that. DS front right. Put this here. So our DS right is looking directly to the right. Our DS front right is actually just looking straight, except we have two in the front. So that kind of confused me a little as well. DS front left, we can put it here. We have our line sensor in the front. And lastly, we have, this is our start module. Since we have nothing on this bottom right here, I just put it there. And we can always move these around, space them out so that it's not as compact and not a pain. Okay, cool. Next, we can place our battery connector. It might be better to keep this away from the more expensive important components. I like to put it bottom right. If my microcontroller was on the right side, I might put it bottom left. I don't know, that's just me. Also, a mistake that I made the first time, you want to pay attention to the positive and negative terminals of your battery connector. So by default, hole 1 is negative and hole 2 is positive, but I should have wired it the other way around. I could show you what that might look like later when I actually start wiring, but we're just worried about placement right now, so let's just do that. Okay. Now we want to place the rest of your stuff. So you want to keep the, you want to place your bigger things first, and then keep the parts that are part of the same device closer together for neater wiring. Okay, so I know that the battery connects to the fuse, so we can put this pretty close. And I just realized that I put the wrong screw terminals. Okay, so I'd like to address a small error that I made. I made these screw terminals 1 by 3, but in reality they should be 1 by 2. So I went ahead and fixed that off camera. Alright, let's continue. So you want to place the rest of your stuff. And when you do this, you want to place your bigger things first and keep the parts that are the same device together for neater wiring. So basically, if a capacitor or something belongs to a certain thing, just keep them close together. So I know that my fuse is connected to the battery, and I know that my switch is also connected to the battery somewhere. So we can place it something like this. And we have a bunch of capacitors here. One cool thing about KiCad is that if you click on a capacitor, this is C1, and you go back to your schematic, you can see what it was attached to in the schematic. It will highlight itself. So this one's connected to the microcontroller, so we can put it by the microcontroller. So we can go here and put it here. I think this is a decent spot. And you see these blue lines, these are basically just where it's gonna connect to, or where it should be wired to. So I'm gonna place the rest of these capacitors off camera. Yeah. Alright, so I went ahead and placed the rest of my capacitors. Let's move on to the next step. The next step is going to be wiring. We're going to be making connections. So, as you saw on the PCB, there's some blue lines to indicate what connections you need to make, and you can click route tracks on the right panel to make wires, or you can use X, which I would recommend because it's faster. And some tips, make 45-degree angles when you make a turn. This is just the standard. I think KiCad 8 does that for you automatically. Don't cross wires. If you need to get over or under a wire, you can place a via with the shortcut V, and you can access the other layer, and that other layer is indicated with a blue wire. Don't cross pads or pins. Just go around them. Connect teensy ground pins to any ground on any component. Your teensy grounds are pretty important. And do not worry about connecting the other ground components. We will deal with this in the next slide. Just worry about your teensy pins. Those are just, or the teensy ground pins at least. Those are pretty important. And if you don't know how to lay something out, look in your data sheet. So we are going to look at how we can wire. So let's do an easy one first. Let's do the start module. So as you can see, we have this capacitor in the start module, and the blue line is going from this 3.3 pad to the 3.3 in the start module. So I'm gonna click X, and it's gonna get me into this menu here, and I can, just connect it like that. As I said earlier, we can leave this ground alone. We can worry about it later. And we have one more connection to make on the start module, and that is this one to the microcontroller. So as you can see, I'm bending it, and every time it turns, it's a 45-degree angle, which is pretty nice. There's a bunch of different ways we can connect this. This is actually viable because it's not crossing any pads. I like to just go like, well, I guess that works. Yeah, that's a viable wire. Let's see. If I want to cross red wires, let's do this for an example. I don't need to here, but just to show, I'm gonna press V. It's gonna give me this circle. I can place it, and then the wire's gonna turn blue, and then I can cross wherever I want. And if I want to cross over again, I hit V again, and I can go back into the red layer. And I'm pretty sure if you try to cross, it's just not gonna let you, or something like that. Okay, I guess it lets you this one because it's 3.3 volts, but if I want to cross like this one, I straight up cannot cross this one because that is wrong. For these line sensors, I might recommend connecting the power like this. So I go under and I go around the perimeter of the board, something like that. And then wherever the 3.3 volt power line is, I can connect this to, okay. I can connect it like so, like that. So 3.3 volts, and these are connected like that along the perimeter. Same with these ones. It's pretty self-explanatory. I think that's pretty much all for wiring. So you just want to connect these blue lines to each other. Everything except for ground. Except for this teensy. Like this teensy ground, I can connect it to this pad right here. There should be a couple more. Like I can connect it to that one. We'll connect the rest of these grounds to ground later, but I'm going to go ahead and wire everything off camera because it's kind of boring. Alright, so this is what it looks like after wiring. Yeah, so as you can see here, most of the blue lines are gone. Some of them are still here, like this ground. We need to make a lot of ground connections to things. As you can see on some of these connectors and screw terminals, I did connect it to a ground of some capacitor or something like that. You don't necessarily have to. I would only do that with the TNC one, but if it makes you feel better, you can. Okay, so next we are going to make our ground connections. So to do this, first you're going to click on Add Field Zone on the right panel. You want to make sure that you have F copper selected. Click a corner on your PCB and the menu should pop up. And at the top left, there should be some layers saying front copper, back copper. Under net, you want to hit ground and then hit OK. And then you want to click the other 3 corners of your PCB to place the dimensions, and then hit B to fill in the zone that you made. So what that looks like, I can show you. So let's hit front copper. We're going to add a filled zone here. And we're going to select the first corner, which is, let's do this one. And this menu pops up. So I want to select front copper and back copper. And then in this field right here, we're going to select ground. So now we can place the other dimensions. Alright, select the other corners of our PCB. Make sure I get this right. Okay, nice. And now we can hit B and it will just fill in those areas for us. Yeah, looks pretty cool. All of our blue lines are gone that are indicating that we should connect stuff. So that is very good. Alright, next up we have mounting holes. This is completely optional. I know the first bot that I made, we secured the PCB to the chassis with tape. I don't think I'd recommend that, but mounting holes will allow your mechanical person to put screws in the PCB to mount it onto the chassis. Alright, let's go ahead and do this. So I'm going to hit A. We're going to add a footprint. You just type in mounting hole and choose the type that you want. I want 3mm because my mechanical person said that. And we're going to choose the pad. So let's put one right here. Looks like there's room in the corner. And you can ask your mechanical person about this as well. I'll just copy paste that, put another one right here. 2 should be okay. I'm not mechanical, so it's not really my forte, but yeah, if you have questions, just ask your mechanical person. Alright, next. You could put a cool design on it if you want. I put a link to a YouTube video on how to do that here. You basically use Inkscape, you convert it to a DXF file, and then you can import your DXF file into KiCad. It's optional, you definitely don't have to do it, but it looks cool, so I can show you mine. So we can go import graphics, and then we hit this folder. We can look at some graphics. I have the Mitsubishi logo here. You want to print it on the front silk screen. So this is basically not going to interfere with any of the wiring. It's just going to go like on the very top. Yeah, that looks pretty good. I can put it here. Cool. And if you want to put text on it, there's a text thing right here. Make sure you select front silk screen. And you can say, I need help. You put whatever you want, it doesn't matter. Shoot. Okay, cool. Alright, we're almost done. We're gonna use design rules checker. So, we can go up here. This is kind of like the electrical rules checker in the schematic. So, we can run DRC. Let's see what it gives us. 0 errors. Wow, that's crazy. They have some warnings here. Silk screen clipped by board edge. This is not a huge issue, because silk screen is basically just the stuff that goes on top. It doesn't really have anything to do with the pads, so we're fine for most of these. Let's see, text height out of range. I don't think this matters too much. She's going to kill me for that, but that's okay. Okay, I should not have moved that. I'm sorry. Anyways, looks like we're error free, so that's very good. But if you do have errors, some of them are definitely ignorable. You can check with me, or you can check with your mentor about any of those. Okay, so the last thing you want to do is export the Gerber file so that we are able to order it off of JLC PCB. Okay, so here's a link to instructions. Okay. Yeah, so this is how to generate Gerber and drill files in KiCad 7. I'm actually using KiCad 8, but it's close enough to where it's not relevant. So I can go, I'll put this on my second monitor, I'll just read off of it. Okay, so it says go file, fabrication outputs, right here, and then Gerbers. It's going to be a .gbr file. Okay, next we're going to select our output folder. I have it right now as Musubi Gerbs. You could type whatever you want in, and it will make a folder for you. It's telling me to select layers. It's telling me to select front copper, front paste, nothing down there, front paste, front silk screen, and a bunch of other things. But you can read that on your own. Edge cuts as well, and then some other stuff. Okay, and then it says some general options and Gerber options. It says select plot reference designators, which is right here. Select check zone fills before plotting, right here. Select use proto file name extensions, which is here. And select subtract solder mask from silk screen, which is here. Everything else was checked by default, so I think it's just good to leave those. And then after that, you hit plot down here. And yeah. I think it just generated a bunch of duplicates, but that's okay. Yeah, so you plot those. And then next, you want to generate drill files. So you click this one right here at the bottom right. This is telling us to check off certain things. So we're going to do use alternate drill mode, which is here. Absolute for drill origin. Drill origin is here, absolute. Millimeters for drill units, which is here. And check decimal format for zeros format. Decimal format. Yeah, okay, so we're good. And then after this, you want to hit generate drill file. I'm not going to do that because I already did. But it would give you a bunch of messages right here saying that it generated all of those. And there is an optional step, generate drill file, map file. Definitely optional. But it's just additional information for drill holes. Yeah, so it's just more information, but there is a lesser probability for error. And yeah, all of these instructions are on the link that I showed you. But pretty much what you want to do is go to wherever you have those files. This one is in here. It's in Mitsubi GURPS, and you want to make a zip file. So I already did that here. Here's my zip file, and as you can see, we have all this stuff in here. And if you want to see what your PCB looks like, you can actually go into JLC PCB and you can upload it. So you can add your Gerber file. You need to upload the zip. So you put it in here. It's gonna upload your files. It's gonna show you what it should look like. So as you can see, yeah, this is mine. And if you want, you can click on the Gerber viewer. Oh man, whatever. You can click on the Gerber viewer and it'll show you what it looks like more like zoomed in, and you can like rotate it around and stuff. For ordering, you can just leave it to V, but yeah, if you want to know more about ordering, you can ask me questions. Okay, cool. Finally done. The next thing you're going to be doing after this is soldering and debugging. I'm probably not going to make a video for it, but yeah, I think that's all. So, if you enjoyed this video, please make sure to give it a like and maybe subscribe. If you have any questions, please make sure to put it down in the video below, or you could text me on any social media that I might have. So yeah, thank you for watching and good luck on your PCB.